Well, first of all, thanks for inviting us to talk about Video Indexer. I manage the data science team for Video Indexer. Video Indexer is a Microsoft cognitive service developed here in Israel mostly. And our business is to unblock video insights, and we do it mostly with machine learning. So, okay. So first of all, I'd like to tell you a little bit about the story that led us to do video indexing. So first of all, a few questions that are worth asking. So what does it take to build a machine? This is the classical artificial intelligence problem question. What does it take to build a machine that understands the contents or understands the video contents? And video is both visual and audio channels of the input, and also the interconnections between them. Okay, so it's not just visual plus audio, visual channel plus audio channel equals video. It's sort of a 1 + 1 = 3, and I hope to demonstrate it in one of the models that I'll be showing. And then how will the classical video experience evolve once we have it? And I'm not only talking about the consumer experience of how I watch YouTube, I'm also talking about major transformation in the enterprise, where enterprise accumulate huge amounts of video data, and they have a challenge to manage it, to search it, to delete it, to understand what they have. Most of this video will not even be watched or listened to. Okay, most of the enterprise video, it just remains buried and just waiting to be used. And the way to use it is with artificial intelligence, not human intelligence. A few numbers that brought us also to this project is that Cisco projects 80% of internet traffic to be video by 2021. That's 80%. And also other analysts are expecting $40 billion enterprise spending, not consumer, just enterprise spending on video management by 2019. So it's a huge market. And there are a lot of challenges in video understanding and video indexing, which is part of the understanding. Now, before I jump to the demo, just to show you how video indexing looks like, I just want to give you a glimpse. The input is a video file with both audio and visual channels, and the output is structured data. Okay, that's how we perceive video indexing and video understanding. Here we can see, for example, that faces have been recognized as part of the indexing. And near the face, we can also see where that person appeared in the video. We also have a transcript, which you don't see here, keywords, annotations, sentiment. I'll go over it in the demo. I just wanted to make the point that we take an highly unstructured data and transform it into a highly structured JSON file with all these insights that can be searched and managed very easily. As for just briefly a few business cases that we have found, video content management, many types of marketing, learning scenarios, security, think about it. Videos of security, you just want to go to the place where something happens, where you hear a glass break or where you hear a gunshot. Social listening, tons and tons of use cases. And it's actually not very surprising because after content has been digitized and now we have fast access to it, the inevitable next phase is to also transform the understanding of the video and not require a human to watch it. So have something else, have a machine that can watch it for you and bring you more value more efficiently from the data contents. Exactly like the transformation that was done with text, right? Google and all the other search engines, they work mostly on text. That text used to rely on manual tagging, on labeling in libraries, and now text is available for everybody with search. The same thing is going to happen when, with the high digitization of visual and audio contents. Okay, so a demonstration. Okay, there is no voice, but Soon we'll see Katy as well, you see? So now I can do queries like where both these people appear, where one of them appear without having to watch the whole video. This is based on a 200K celebrity model, but we can also add, the customer can also add their own faces. So we have a bring your own faces. This is done using transfer learning on the original convolutional neural network, and then the enterprise trains the base model that was trained on celebrities to recognize its own people. So it's a customization layer on top of the face detection, on the generic face detection and celebrity detection. Next insight is keywords. So we do provide a transcript. I lost the, oh, here it is. We do provide a transcript, but transcript can be very long and very boring and very time consuming. So we have summarization. And in this case, we see that the keywords in this interview are technology company, technology, data, security, and government. And you can also jump to the exact place. Since we don't have audio, unfortunately, you'll have to believe me that they are now talking about, in this place, they're now talking about government. And how the government is, the US government is causing concerns to Box's business. And I'll go to it in a minute. I'll come back to it in a minute. We also have other types of summarizations. So we have visual annotations that are from the individual frames. So if I go here, I'll know that there is sky detected. Again, I can go directly to the point without having to watch the whole video, which is the whole point of what we're trying to save. We also have brand detection, which is very important in many scenarios. So we know that Apple was mentioned here, and this is disambiguating Apple, the fruit, from Apple, the brand, again, using NLP machine learning. It's both, giving the customer a catalog of brands, but also, like, more importantly, it won't be highlighting all the Apples and all the Foxes and all the United as words, but only those that are disambiguated as brands. It's a topic for a whole different talk, but it's something that I wanted to show. One more thing is sentiment analysis. So we can query now, after we have these insights, we can query when Aaron Levy, Box's CEO, talks about the US government in a negative sentiment and go directly to that point in the video based on these, do this search based on these insights. Okay, so we don't have voice. Here, I'll just tell you that here he's talking about privacy issues and with the US government and how Box is going to deal with them. By the way, in the transcript, we also provide OCR. I'm going to elaborate about this in a few moments about OCR. So let's see the models that we're doing, the machine learning models. Okay, here is the flow, the audio flow and the visual flow, some of the models that we do. Just very briefly present some enumeration of what video indexing consists of today. So this is a very comprehensive service doing things from NLP like OCR for video that I'm going to show you in a second. Also things like language identification that I'm going to talk about, which is purely from the ODL channel, and many, many other machine learning models that are helping in the understanding of the video. Okay, now let's go to the machine learning model. So OCR lies between the visual and audio channel. Okay, OCR is language. Language can come as text in the visual channel. It can also come as speech in the audio channel. So this is kind of in the middle, and we're going to use both these channels in order to understand what OCR is in the video. What are the challenges for extracting OCR from video? So processing each video frame separately creates a lot of noise. I'll show you an example soon. Because a video is much more than the sum of its frames. Okay, video is also the connection between the frames. And the common patterns that we have seen are that single characters, like an S exchanged with something else, Text is also identified in some frames where there is no text. So many things look like letters, especially if you're multi-language in your OCR, in your like whatever you do. So it's amazing to see how many things actually look like letters in some language. Okay, so this is another issue, and then a partially hidden text that is identified as broken strings. Here's an example. So you see, for us, cognitively, very, very easy to understand that this is the word Microsoft. But if I just take a few frames, I'll just get a lot of fragmented strings that I do have to consolidate. We chose to solve this problem with the classical unsupervised approach. We do multi-sequence alignment clustering and voting in order to understand which lines of OCR we actually see, and then consolidate them into something that is less noisy, much less noisy. Multi-sequence alignment is borrowed from bioinformatics, but it also has application. It's also coming from other domains. We also boost the confidence with the video transcript. So if we have a tie from the visual channel, we can break the tie with the audio, with the transcription from the audio channel. And we also use language auto-detection in order to reduce the noise. This is actually the simplest step. Because we are doing multi-language detection, we only take so there is a long tail distribution, and we only take the most popular languages. This is on a benchmark, increases dramatically the effect of noise filtering, noise cleaning. It reduces the noise significantly just by taking a few languages, but that's easy. Let's see the machine learning behind the scenes. So what we do, we take every detected line of OCR, and we start building a bottom-up clustering using the distance that the multi-sequence alignment gives us. And at the end of the clustering, what we get is this kind of tables. Each table corresponds to a cluster. And by the way, we also merge clusters that are between them very close. I won't get into the details, but like in almost every bottom-up clustering algorithm, there is a condition that merges the clusters together. And here we can do voting. So what we've observed in many videos, that while OCR gives you errors in almost every string, it also depends on the sampling rate, actually if you look at the bigger picture, literally, you can see that the voting gives you a pretty good consensus string. So this reduces dramatically the number of errors, so we can actually correct the errors from one frame to another. Now, what do we do if we have a tie? In this case, we resort to the transcript. So if we have a few Microsoft in the transcript, we'll add them to the voting with some weight and be able to break ties based on the transcript. And this is where, if you imagine yourself watching a video and not understanding what word is written on a visual text, many times you'll find yourself saying, okay, like listening to what's being spoken and then resolving it. So try to pay attention to that, and you'll see that you actually do that very often. This is where we got the inspiration for. Now, after clustering, what we do is if a line is not assigned to any cluster, because there is a minimum condition for a cluster, or if it is a very short length, we discard it. Else, we replace it with its consensus string coming from the cluster. And otherwise, if there is no consensus, we just keep the OCR line as is. And after that, we have a lot of lines that are related to individual frames. Then we have another consolidation step. We take every 2 consecutive frames that have OCR detections in them, and we minimize this equation. Like how do we get the least distances between pairs of strings that appear in the 2 consecutive frames. Okay, so here we have the output of OCR on 2 consecutive frames. This is after the clustering, and we need to do this assignment automatically. After this has been done, if it passes a certain threshold, we consolidate both frames, and then we have much less fragmented noise, and we're actually mimicking what we as humans do when we see a video. We actually do a lot of consolidation. It's a theme that we see all the time in video indexing. Okay, I just have a few minutes more, like a couple of minutes more, if you don't mind, like 3 minutes more. Okay, that's great. Auto language identification. Now, this is a vision conference, but video is very close to vision, and video is not complete without the ODL channel. But I did choose to show this ODL model because it uses convolutional neural networks that are very popular with you guys. And I just want to show you how we actually can see the ODL channel. I don't know how many of you have done that with audio, but it's very nice and very close to what you guys are doing with convolutional neural networks on vision. Motivation. So we have enterprise customers at Microsoft. This is our main business. They have batches of files. You know, even small companies today have exponentially growing video assets. Even small companies can no longer rely on manual tagging, even for language. So we have like medium businesses, they have contents in 3 languages. They want to index it. Now they have to go file by file and say, this is German, this is French, and this is Italian. Okay, this is a deal breaker for video indexing for many of the companies. So we are introducing language identification. It's also like currently we detect just one language, but we hope to expand it to multi-language. So if language changes in the video, take for example a news broadcast in Israel, it almost always will have 3 languages: Hebrew, Arabic, and English. And you want to transcribe it. You want to give a full transcription regardless of the language. The solution that we have chosen is not the traditional solution that to try to hear the phonemes and have a distribution on the phonemes. The reason is that this is just not accurate enough for our needs. It has a lot of noise, and the new wave of language identification is actually using deep learning, not very surprisingly. The solution that we have designed is taking a WAV file to a spectrogram. I'll show how we do that. It then classifies with the same model just speech versus non-speech. So this is cleaning of the input. So we're working only on speech, both for training and for scoring. We work on 9-second samples, and we gathered as much tag data as we could. So there is an open research data, it's called the Language Data Consortium. Our team actually did a project of tagging. So we took videos, wherever we could find them, tagged them for language, just did the manual job of tagging them. And also one resource that we have found very useful is the sources that were used to train the speech-to-text engines. Okay, they are tagged for language, and they are very diverse. Diversity is the main challenge here. We're using ResNet as the architecture. Now, in the 1 minute that I have still, I'll just show you what we do. We take speech, either train or just for training or for scoring. We run it through a speech-on-speech classifier that is built in the same way as the language identifier classifier. Using the infamous Fourier transform, we convert it into a spectrogram, and this is the visual data that we input into the convolutional neural network. Okay, the convolutional neural network, your vision guys, so we'll just say that it takes parts of the visual input and aggregates it into higher level features, and then uses a fully connected network in order to classify. Okay, the main challenge is how to model the language rather than a source. Oops. The spectrogram representation is very sensitive to the source, so you have to have a lot of very diverse sources in order to cancel these effects. Otherwise, you'll just be modeling that this is coming from television and this is coming from phone as ODL aspects. And also trying to derive higher level features, which is our current work. I'll skip that demo, you can probably imagine it. This is going to come soon in Video Indexer. Our results are on an enterprise data benchmark. Okay, so this is our main business, is with 95% accuracy, 95% recall, using the convolutional neural network borrowed from Vision in a runtime factor of 10%. So if the lecture is 1 hour, we can do this in 6 minutes. I don't have time to show a demo, and I don't have audio, but this is detecting Chinese from other languages. If you want to see it more, feel free to reach out to us. We're hiring students in full-timer. This is my email, and this is videoindexer.ai. This is our website, and you're most welcome to come and play with it. Email us with ideas, with requests. We're more than happy to hear you. Thanks very much.